Hey everyone, so today we're going to be determining the exact value of a trigonometric function, and today we're going to be looking at the cos of 5 pi over 12. So the first thing that we're going to do is we're going to convert 5 pi over 12 to degrees. So to do that, first we're just going to look at pi over 12 and what that is as a degree. So we have pi over 12. So, okay, the marker's a little bit weird, that's okay. So to convert this to degrees, what you do is you just take 180 and you divide it by 12, which is 15. So this equals to 15 degrees, but it's 5 pi over 12, so that means that we have to times 5 by 15. So in reality, 5 pi over 12 actually equals to whatever 5 times 15 is, and that's 75. So we know that 5 pi over 12 means 75 degrees. So now that we have this, we need to think of angles to add together that equal to 75, but nice angles, angles that fit under the fractions of pi. Sorry, I was looking for a word to use there. So what fractions of pi can add to 75 degrees? Well, we know that pi over 6 equals to 30 degrees, and we know that pi over 4 equals to 45 degrees. Well, hey, if we add those two together, doesn't that equal 75 degrees? Yeah, so we're going to be working with pi over 4 and pi over 6. So now now comes the tricky part. We're going to be using one of those cosine and sine adding equations. Don't try to memorize those. Trust me, it's not worth it. So today we're going to be working with the cos adding, because we're trying to find cos of pi over 6 plus pi over 4, because that will give us 5 pi over 12. So, like I said, don't try to memorize these. You can look this up because it's not worth it. So, this is basically saying we need to find the cos of x, and x in this case is pi over 6. So, cos of pi over 6 times the cos of y, which in this case is pi over 4. So, cos pi over 4, like that, and then it's weird, the plus for cos is actually minus, so we put a minus here, minus the sine of x, so minus sine of pi over 6 times the sine of y, which is pi over 4, so sine of pi over 4. Okay, so see, nice big long equation here. So now we can actually find these values and put them in instead. So cos of pi over 6, if we think of the unit circle, right? Pi over 6, okay, that's 30 degrees. So we're thinking of it, okay, the value for cosine at pi over 6 is root 3 over 2. So we can have root 3 over 2, put that in brackets, times by cos pi over 4, and that is root 2 over 2, or 1 over root 2, it doesn't matter, just this is the more proper way. It doesn't matter which one you use, it's the same number. This way is just so the radical isn't on the bottom. And then it's minus sine pi over 6, which is 30 degrees again, but this is a half, right? It's halfway up the circle, or halfway up that section of it. And then sine pi over 4, which is again root 2 over 2. So we can multiply this all out. So root 3 times root 2, well, that's root 6. 2 times 2, that's 4, minus root 2 over 4. Perfect, they have the same denominator. So this turns out to be root 6 minus root 2 over 4. And that's the exact value. Now, if you were to use 1 over root 2 instead of root 2 over 2, your final answer would be root 3 minus 1, what is it, over 2 root 2. So both of these answers are correct. It just depends on what value you use for pi over 4. So anyway, I hope you found that helpful, and have a great day.